Welcome to the Inside Java podcast. My name is David Delabassi and I'm your host for today's episode 21. Today I have with me Brent Christian to discuss JEP 421 and finalization deprecation. So Brent, welcome. Can you first introduce yourself?
Yeah, I'm Brent Christian. I work the Java Core Libraries team at Oracle.
Short and sweet. Thanks. So today we will discuss JEP 421, which is part of JDK 18. JEP 421 is about deprecating finalization for removal in a feature release. And in order to discuss that JEP, it would be useful to set the context and discuss finalization. So finalization is not new, as it's something that we have in the platform since the beginning. Can you refresh us on the concept, the core idea behind finalization?
Sure. So as you say, finalization in Java goes back to the very beginning in Java 1.0. And that's also the same with garbage collection. If you're a developer of a certain age, you may have come to Java when it was new with some experience of C and C++. So garbage collection was a new feature you were getting. So the garbage collector will allocate your objects for you, deallocate them when you're done using them. So this was something new to C and C++ programmers. But to do anything really meaningful, your program needs to interact with things more than just heap memory. You need to probably read and write to the disk, maybe communicate over the network, maybe put some graphical elements on the screen. And so using these sorts of things is managed separately by the operating system. And we call those things collectively resources. These are things that need special permission to talk to the hardware, and the system keeps special track of them. And so you let the operating system know when you want to use them, and you let the operating system know when you're done using them, so some other program can use them. And so this is something that the garbage collector is not aware of. That's something that you need to specifically, when you're done using something like a file descriptor, you need to specifically close it. And so you can see in classes like input and output stream, there's a close method that needs to be closed. And so if that close doesn't happen, then that resource kind of gets lost because the system thinks you're still using it. And so finalization is a way for the garbage collector to get involved, to making sure these resources get closed. And so to use a finalizer, you override the finalize method, and you can give it code that will call methods that will let the operating system know that you're done using that resource.
Okay. But given that we're going to discuss deprecation of finalization, that means that everything was unfroze, that finalization is somehow problematic, right?
Yeah, that's true. It was evident not too long after Java came on the scene that finalization had a number of problems with it. When we were writing JEP 421, I think we had over a dozen at one point. What we figured we had to whittle it down to cover the most important ones.
Such as?
One of the problems with finalization that I think most people are aware of is that there's a unpredictable latency to when a finalizer will run. A garbage collector's most important responsibility is managing heap memory, and does that with various priorities. And so running finalizers does not always fit in what its main job. So sometimes it can be quite a while before a finalizer runs. And in fact, in the specification, it's not guaranteed to run at all. So as far as using this as a way to make sure all of your resources get closed and can be used again, that's pretty much not what you want.
So that means that at the end of the day, it might happen that those resources that you would like to be closed might not be closed at all.
Yeah, that is a possibility.
Okay. Which might lead to some severe issue.
Right, resource exhaustion.
That's hard to say.
That's right. Resource exhaustion is no joke.
Okay. What other weakness can you talk about? Because that's not the only one, right?
No, absolutely not. There's a finalizer is basically allowed to run any code. And one of the most significant things that it can do is it can take the reference to the object being finalized and make it reachable again. It can stuff it into perhaps a static reference, and then this object that was uh, about to die comes back to life. It's resurrected. And this comes into play in some of the security problems that finalization has.
Mm-hmm.
Another problem with finalization is that it is always enabled. As soon as your object is allocated, it is eligible to be finalized, and there's no way to cancel that. So if you do your own cleanup promptly of your resources, the garbage collector still needs to do extra work to keep track of that finalizer and probably run it once your object becomes unreachable.
Okay. And wasn't there an issue also regarding the threading of finalizers?
Yeah, the thread or threads that finalization runs on is not specified, and this can lead to deadlocks, and it can also make a thread that is otherwise single-threaded become inherently multi-threaded.
Mm-hmm. Okay. And wasn't there also issue regarding performance? I mean, does finalization impact the overall performance of an application?
Oh, yes, absolutely. Having finalizers makes extra work for the garbage collector. It's extra things that the garbage collector needs to keep track of, and it can also increase the amount of memory that the GC needs to use to keep track of finalizable objects. So, yeah, it's definitely a performance impact.
Next to that, finalizer are not that easy to use. Or is it just me?
No, it's definitely not just you. It seems like something simple to do. You override the finalize method. You have access to, the context object through this, so you can write whatever close code you need to do. But there's a couple things that make it difficult. One is that unlike constructors, which will orderly go through constructing your object sort of class by class through the class hierarchy, uh, the compiler does not help you clean up. And so if you're overriding a method on a class with a finalizer, you have to be sure to call the super.finalize to call your superclass's finalizer. And if any exception occurs during your finalizer, that is just ignored, and you never hear about it. And so any problems with finalizers, any exceptions thrown by these resources that you're closing, which can happen. Someone can pull out the network cord or unplug the disk, hopefully not, but you don't hear about those things, and that can mean that your resources weren't closed properly and they get leaked.
Clearly, we haven't depicted a good pictures of finalizers. The good thing is that years ago, well, we understood that it was an issue and we started to roll out alternative for finalization. Can we talk about those alternatives?
Yeah, that's right. So kind of the gold standard, I would say, in Java for resource management came in JDK 7 with the try with resources statement. So instead of trying to account for exceptions yourself using a finally block, the try with resources statement allows you to declare your resources at the beginning of the try and just write the code for what you need, how do you need to use those resources. And then those resources are guaranteed to be closed, whether the code executes correctly, or if any sort of exception happens during your code, or if an exception happens during closing one of the resources. It's the safest way to write code with resources.
And if I recall correctly, that was called automatic resource management.
That sounds right. I'm not sure.
Yeah, I think so. And that's done using the auto-closable interface, so it's easy.
Oh, absolutely. Yeah. So all that you need to do to, if you want to write a class that can work with try with resources, is implement the auto-closable interface, which is just one method close, and then your classes can be used with try with resources. It's easy to use.
And then in JDK 9, I believe, we have introduced cleaners, which achieve similar goals. Can you go over the cleaners API?
Yeah, cleaners is a similar in spirit to finalizers, but it has almost none of the disadvantages of finalizers.
And in a nutshell, how does it work?
So to use cleaner, you can register your object with a cleaner and write a cleaning action, which is just a runnable. And when your object becomes unreachable, the cleaner will run the cleaning action. And in your cleaning action, you can have any code that releases resources.
So you say it's a runnable. Does that mean that you don't have the threading issue that we have with finalizers?
It is true that the threading issue with finalizers is not present in cleaner. Finalizers, the threads for finalizers are shared across all of the VM instance, and that means that finalizers from one library or one class can, if they deadlock or if they take a long time, they can prevent other finalizers from running. With Cleaner, you can control the threading yourself. You can, if you choose, you can pass it a thread factory to create your own threads. Or by default, Cleaner will create its own separate thread, which isn't used by any other cleaners.
Mm-hmm. Okay. Now, why would you want to use cleaners versus try with resources? Because, try with resources are pretty easy. So why do we need cleaners? Why would you use one versus the other one?
Right. So in the try with resources case, that exists within a single try block. It's within a lexical scope. So if you have longer objects that need a lifetime longer than just a single code block, or have kind of an unpredictable lifetime, that would be a better time to use cleaners.
Okay. So we've talked about finalization. We've talked about the issue related to finalization. We also talk about the alternatives that we have today in the JDK. Let's now discuss about JEP 421, which will be part of Java 18. So the title of the JEP is Deprecate Finalization for Removal in a Future Release.
Right.
So in Java, deprecation is always a multi-step process. And if we look back, well, we have already kind of started that deprecation effort. Finalizer are deprecated since JDK 9, if I'm correct, right?
That's right. It was the finalize method was deprecated in JDK 9, although moving away from finalization is a kind of a path that started quite a while ago. I think it's been generally regarded as something to be avoided for quite some time.
If you look at the finalize method javadoc, there is a statement, and it's a bit scary. It's clear that you shouldn't use finalizer. The javadoc is clear about that. Just check the javadoc and you will see what we mean. Now, JEP 421 is one other step towards that finalization, deprecation of finalizers. What are the goals of JEP 421?
Well, JEP 421, which I wrote along with Stuart Marks, although considering the content, maybe I really wrote it with his alter ego, Dr. Deprecator. So JEP 421 is really putting the next stake in the sand as far as moving away from finalizers and eventually taking them out of the JDK. And so it's not a lot of actual code change. The behavior of JDK won't change in this respect, but it's really kind of an alert to developers that it's time to, if you use finalizers, to get serious about moving away from them. So as a way to assist developers who want to learn how their code might behave when finalizers eventually are disabled, this JEP also adds a command line option to disable finalization. And so this is Definitely not something you'd want to use anywhere besides a very controlled test environment. There's still finalizers in the JDK itself that are supposed to be running, so those would be disabled as well. But if you're able to put together kind of a good test of your application, you can test it once with finalization enabled and look at what sort of resource usage you're seeing, and test it again with finalization disabled. If you're seeing that things aren't being cleaned up or behavior of that nature, that's a good sign that you should do some more in-depth investigation of what finalizers might be used when your application is running.
Moreover, there's also a new GFR event that could be useful for those investigation, correct?
Yes, that's right. In JDK 18, we also added a new JFR event called JDK.FinalizerStatistics that will tell you for every class that runs a finalizer, it will tell you how many finalizers of that class were run, how many still remain yet to be finalized. So that can be a very important metric for finding finalizers when your application's running.
Mm-hmm. You mentioned the fact that the JDK itself is still using finalizer, right? And in French, we have this saying which say, if you want to change things, you should start with yourself first. So does that mean that we're going to remove finalizers from the JDK? I assume that the answer is yes.
Yeah, the answer is definitely yes. So it's, it may look on the outside as, kind of a do as we say, not as we do, since we still have finalizers in the JDK ourselves. And those are in the process of being removed. And actually, a lot of finalizers that used to exist in the I/O and networking classes are no longer yet there. So there has been a lot of work in that area already. But in terms of timing of JEP 421, now that we have good alternatives to use instead of finalizers, we wanted to kind of get this out there kind of as soon as we could put it together to give people as much time as possible. And, that includes us in the JDK2 also to do something else with our finalizers as well.
Okay, so we already started to remove finalizer from the JDK, but the JDK still have a bunch of finalizers.
That is correct.
Okay. So as we said, JEP 421 is another step towards removing finalization completely from the JDK, from the Java platform. It will happen in JDK 18. Now, can you already discuss about the subsequent steps, so the steps after 18?
Yeah, I think there's a number of next steps that would make sense. Of course, in the JDK, we need to remove our finalizers and convert that to other resource management. And then I think at some point it would be helpful for developers to be able to get a warning if finalizers were used during their program's execution. Finalizers are kind of between exceptions not being thrown from your finalizer and, resources not being released, not being an apparent event. If those things happen, it can take a while before something happens to make you know that they're happening. I think some sort of fail fast warning would be useful. Also, eventually, once the JDK has no more finalizers, and we think most code doesn't have finalizers, there'll come a time that we want to disable finalization by default, but leave in the option to re-enable it for any code that still needs it.
Yeah, I guess it's still early. It's still a bit early to talk about a timeline for such work, right?
Yeah, I would hesitate to make any specific time predictions. I mean, we want to get this going as quickly as we can, but definitely don't want to pull a rug out from anyone before they have a chance to get ready.
Okay. So I guess that we can recap here. If I got this right, so JEP 421, the finalizer behavior doesn't change in JDK 18. By default, nothing will happen. It's only if you are using the specific command line flags that finalizer will be disabled. And this is something that we are doing to help developers to understand where finalizer are used in their code base, right?
Yeah, that's right.
Okay. So as a conclusion here, what would be your call to action for developers?
Yeah, the first thing would be, if you already know you have finalizers in your code, have a look at try with resources and cleaner.
Mm-hmm.
If you're not sure, search for the word finalize in your code base. And you can also use tools like JDeprecation to search over all of the code that your application uses to look for deprecated methods such as finalize.
And we also have that GFR event that we mentioned, so that's something that we can use. So I guess that at the end of the day, we are encouraging developers to think about a world where finalizer won't be available in the GDK anymore.
Yeah, that's exactly it.
Yeah, so it won't happen overnight, but clearly we are starting to give the tools to think about how to cleanly remove them if they are still used in existing code base.
Yeah, precisely.
Okay, cool. Well, I think that we have a good overview of JEP 421. So I'd like to thank you. But before we close, this show is called Inside Java. So can you give our audience a peek inside the day of Brent?
Okay, sure. Yeah, the day of Brent. Well, I think like maybe most people in our industry, I'm working from home now. Although it might be interesting to know that I've worked from home starting significantly before COVID. When my then fiance, now wife, was finishing school, we kind of decided where we wanted to put down roots, and thought we'd give Seattle a try, which didn't really have a big Sun engineering presence at the time. But my then employer Sun, now Oracle, was kind enough to let me do that. So I will say that the teleworking tools have come a long, long way since those days. So I think we're in a pretty good spot with Slack and Zoom and those sorts of tools that we have now.
Except the tool used for doing remote podcast, right? Anyway.
Not as bulletproof as you might want.
Okay. Well, anything you'd like to add before we close?
No, this has been fun. It's been fun being on. Thanks for having me.
Thanks, Brent. Thanks for your time today.
Sure.